gas on our land, and so we want to tell you a little bit about our story. You'll excuse me doing it this way, it helps me to think of what I want to say. Now, we have titled our talk Fact or Fiction, and you'll see as I go along exactly why that's the choice. This is a picture of our ranch back a few years. It was beautiful. We, as the introducer told me, we ranched for about 40 years. We have always had oil and gas on our land, but as farmers, we believe that we have been environmentalists before the word was even popular. Because as you realize, as farmers on the land, you look after the water, the land, the wildlife, and the people that depend on it for life. It's caring, it's being a steward, and part of your, I guess, qualities that you get from being on the land is you notice when things are out of balance, and you start to ask questions. Now this is just one section of our land. The squares on there are well sites. The longer lines are pipelines, and there's access roads. Our house is the bottom corner, and the little blue dots are water wells. So you'll notice there's a lot of activity around us. And we were happy enough with oil and gas on our land. We looked at it as added revenue, but farm prices weren't good. But when something started to go wrong with our water, we started to question that. Energy has been developed in our area for a number of years. The major plating extraction happened in the 1980s. Two companies did a lot of drilling, and they used water out of the aquifers to bring the oil to surface. That was called water flood at that time. And just as a point of interest, you'll notice that one of the companies was instructed to water monitor by the government, the other one wasn't. And these companies have changed hands many, many times, almost to the point where we said they should have had peel and stick labels. Water started working out of our taps in 2005, and this sparked a lot of interest. The gas in the water from our water wells was tested by energy companies, the University of Alberta, and Alberta Environment. This is just showing you what kind of testing happens summer, winter, it doesn't matter. Isotopes tell them the signature fingerprint of the gas. In 2007, Dr. Carlos Littlebox, who spoke here last night, did some research with the information from our water well, and by plotting the isotopes of our water against the isotopes of the resource wells in the area, he selected a few possible sources of contamination, which were energy wells that were drilled to 1,760 meters in depth. Now, our water investigation was originally under Alberta Environment. It was handed over to the ERCB, we suspect because of the energy gases in it. 5 years later, the ERCB, now in their report, finally agrees that yes, the water in our gas, or the gas in our water is thermogenic, meaning coming from very deep down. It, although the ERCB have said they have not been able to identify a particular site. We say it's like playing hide and seek with a 3-year-old. You know, when you don't want to hurt their feelings, you don't look right away for them. And what's happened in our area is that they've looked at about 9 of 50 or more sites, and in 2009, allowed the companies to commingle the gases, which makes them much more difficult to identify and trace. Now, often when they talk about gas in water, especially water wells, they say, oh, it's biogenic, it's from bacteria, it's from decay. Well, this comes directly from a most recent report that we received from the ERCB, showing the biogenic gases up in the top, the thermogenic gases down at the bottom. Our well falls within the thermogenic gases with some mixture of biogenic gases. So it dispelled the myth that it was always biogenic or could be biogenic. The other method, which often is brought up with the other fact, is that the gas in your water could have it then got to surface by faults or natural fractures in the ground. So in 2010, a study was commissioned by the ERCB to look at the natural flow of groundwater in our area. Now, our water well is, you point to the lower right here, that's approximately where our water well in our land is. The natural flow of water is from the northwest to the southeast. And to the northwest of our water well has been quite a bit of development years back by Pan Canadian. Now, the findings of the study said that the connection, there is definitely a connection between the Encana water wells and the Campbell water well. But their main conclusion was that the pathway for the movement of the gas from the deeper formations to the Campbell well may have included gas migration along fracture zones at depth, maybe deep down, and lateral migration within the aquifer at shallower depths. In that report, there was no mention of natural faults, but what you'll see is in the investigation, the blue dots are water wells that the Energy Resources Conservation Board looked at. The red ones are the energy wells that they have looked at to date. All of those little yellow marks, plus many more that I could have highlighted wherever there's a black number written, are existing and abandoned energy wells. So they looked at such a small percentage. In the northwest direction from our water well is the area that the previous slide pointed out could be definitely an impact. None of those have been looked at. And in fact, that spider web drilling site there has been abandoned a number of years ago. So when you talk about spider web drilling today, it's not new, but it was not successful. So it's not something I would encourage seeing happen. Now, when we started to connect some of the dots between what we were seeing happen, what was showing up in these reports, we started to realize that fracturing had an impact on our water. So we looked at the drill depths and the frac depths of several of the energy wells around us. The dark blue are the depth of the well the energy well was drilled to. The red and yellow are fracture depths that were done in our area. Interesting that our gas showed up in our water in 2005, and the depth that was identified out was 1,700 meters. So this investigative lifestyle that we've been forced to live, not of our own choosing certainly, has brought us to an understanding that in order to know more about this, we had to get educated. We also had to start to look at facts and sift out the difference between the facts and fiction. And so we chose for our presentation to help you a little bit to do think. CAP's website story, More Facts, Less Friction, and it's on their website about hydraulic fracturing. The first statement they made is that properly constructed natural gas wells protect water. And on the right, you'll see an ideal casing and diagram, and that would be great. The only problem is that we know in the real world that isn't what has happened all along, and that isn't what always happens. The steel and casing break down. Go to the next slide. And this is what the industry knows. Poor cementing, tubing failures lead to gas migrating to surface. Surface case gassing, surface casing gas, which was talked about a lot last night. Soil contamination and aquifer contamination. And in Alberta, when we've had 50 years of producing oil and gas, we know that some of these facilities are old and need to be replaced or totally abandoned. Often abandoned wells are just left to sit. The second claim is that CAP claims there is no evidence of groundwater contamination. Well, I hate to call someone a liar, but they wrote their own report. Migration of methane into groundwater from leaking production wells. And it came out 20 years ago almost, so it's not new. We're just one of many landowners who are living examples of being impacted by their activity. As you'll see, this is 2011 water test results from our well. We have 500,000 parts per million methane. We also have ethane, propane, isobutane, isopentane, or pentane, I believe. When these other things show up in water, that tells you it's not biogenic. And we have a hydrogen sulfide content of 88.5 parts per million, absolutely unsafe. One of the American studies that was done recently in 2011 and 2012 is the testing was repeated, and they have conclusively connected the isotopes in the gas in the water wells in the Marcellus Shale area to the isotopes of the Marcellus Shale gas. And these are peer-reviewed studies. They're not just somebody's opinion. Now, CAP claims that they use no water is needed after drilling. And I said that this is absolutely ludicrous because it's a well-known fact in the industry that if the well stops producing or drops in production, the well is fracked and refracked and reworked to try and increase the production. Now, this is a site of one of the mass fracking operations, and I had the opportunity to have an energy fellow tell us that he was proud to be part of a drill that involved many drill stands on one site, so a multi-spider web drill, 50 pumper trucks pumping water at 17 cubic meters a second. In order to get that much water, they had to pipe it from 2 lakes or a lake, and when it was calculated out, this would be the volume of water going over Niagara Falls for 23 days. Sadly, this man did not understand. He was convinced that we do not have water shortage in Canada, at least not yet. I've also read about propane fracks being considered, and thank you very much. We've already got propane in our water. I really don't want it anymore. It reminded me of a gopher exterminating system that actually is still for sale. They inject propane down the gopher holes and blow them up. And this caused a few problems because the propane flame shot out of other gopher holes and started grass fires. So can we connect this to the Alberta frac blowout that happened in Innisfail, where the fracturing fluids that were put down one well came out another well site's well bore. Fact or fiction? Cat claims that the water used in fracturing is treated and reused in other wells. Well, it seems to be a little bit of a play on words. Treated, yes, they use our treated water in quite a few of the sites. They load up the tankers and go out to treat the wells. Reused, very seldom. Very seldom because the water is very high in salt. The chemicals will corrode their own equipment and possibly even plug the fracture or plug the formation, so they are not used on a regular occurrence. In fact, the water that does come back to surface after they've injected our potable water is often too contaminated to be used and is disposed into deep formations. So I'd just like to make a short comment about, I think it was brought up last night, the Shell has undertaken a project to reuse the human wastewater at Dawson Creek, or from Dawson Creek. And I wonder if people realize that this human wastewater is actually always retreated, is put down the river system. The river does another natural treatment of the water, and it is another community's potable water. This water continues around in the water cycle. It isn't lost. But the fracked water is lost unless by some method they've got an injection well hidden under that tent or something. I don't see any drill stems that show us that that water is coming back to surface to be used by us in the future. Fact or fiction? Industry claims that hydraulic fracturing is safe and regulated by government. Well, I think there's definitely some questions about the safety, otherwise a lot of people wouldn't be asking for moratoriums on it. This isn't just people with fears saying it's not safe. There have been many peer-reviewed studies done. Regulated by government, well, what we've seen in our experience, because our water investigation has fallen into being handled by regulators. They have, well, I guess maybe I should just go to the next slide to tell you what they've done. When we asked who was looking after us in our investigation, this was their quote back to us. The ERCB's jurisdiction is confined to energy development and does not extend to groundwater. And we kind of, what? You've been handling our water investigation for 3 years, and now you tell us that you really weren't doing any of it for us? So we went ahead and we asked Alberta Environment, okay, if you're the protector of water, what are you doing for us? Alberta Environment said that they were being informed by ERCB what was happening, and that after the next set of test results, they would go to Alberta Health and talk about our hydrogen sulfide concerns, but had to have another set of test results. So the next set of test results came in. This was the 2012 gas analysis, and look how it's changed. Methane, ethane, propane, half what it was in 2011, and virtually no hydrogen sulfide. It disappeared. Not according to the people who were testing, because they smelled the rotten egg smell. So we looked at the water analysis, and they are hiding in the information sulfide content, 6.28. The acceptable level is 0.05. They usually say, well, if you've got hydrogen sulfide in the water, it could be caused by bacteria. Look at those bacteria numbers. All below not below detection, below the acceptable levels. I mean, it's definitely not bacteria. So what's causing it? The Canada Health website talks about the acceptable level at 0.05. Talks about the smell of rotten eggs is the characteristic odor, and it says where the common places are that it's found. If it's not found in bacteria, the sulfur is found in fungicides, pesticides, fertilizers. We use natural products. It's also found in industrial waste from petroleum plants, gas works, paper mills, heavy water plants, and tanneries. One of the comments is that shale gas means less greenhouse gas emissions. I put this in because I thought it was funny. Shale gas and natural gas, are we supposed to be thinking that they're entirely different, like two horses, a Shetland and a quarter horse? And as livestock producers, we found that it depends on what you feed them as to what they give off. So maybe we should be asking them what they're feeding the shale gas. Another concern of mine, which nobody has introduced at this point, is how can an industry go after a product that is so uneconomic? They tell us that they have to use lots of chemicals, they have to frack and refrack. They're using our water, which is coming very inexpensively, but there's still a cost of doing that. How can they do that continually? Well, the little fact I found was the number of royalty incentives that there are for extracting shale gas. The blue, red, and orange blocks are all different incentives that the company can qualify for. The green line is the actual net royalty that the company would pay. The net royalty starts to go up at about the 4th year. And for you who have read much about shale gas, they expect that the highest extraction production is in the first 3 years. After that, it drops off considerably. Next slide. So I went to our 2012 royalty information by the government, and they said in the 5-year transition option, which the companies are given, this will provide them with lower royalties in the initial years of a well's life when the production rates are the highest. So they know that they're getting a good deal. CAP claims that once completed, a natural gas well is the size of a 2-car garage. So this is a 2-car garage. This is the 2-car garage on the section near us. All of the squares, again, are energy wells. Pipelines are the red lines. The black lines are access roads. 2.5 acres is a minimum site. Now, this is what they're trying to refer to as a 2-car garage, but we can assure you that it can soon turn into this. This is just a small compressor on our land. Underneath this 2-car garage, the energy industry has a huge, massive basement full of drill stems, pipelines, hydraulic fracturing, or frac zones, so that you soon realize that what you see on the surface is not the only damage that can occur to your land. If that was the 2-car garage, maybe the industrial heartland was the arcade. CAP claims that natural gas producers support the disclosure of fluids used in fracturing. Actually, an ERCB lawyer has stated that the ERCB does not currently require licensees, which are the energy companies, to to provide detailed disclosure of the chemical composition of fracturing fluids. In other words, it's a compound that won't give you the chemical composition of it. In Canada, British Columbia is the only province so far that has legislation, and even at that, they are allowed to withhold from the public any proprietary information. In other words, the chemicals that they don't want you to know about. And so, in order to make you feel better, well, that's fine. CAP has come out with a set of guidelines for fracturing, and they do say that we will support the disclosure of fracturing fluids. That's really nice. A lot of those look really good, but from experience, in 2006, they also came out with best management practices for coal bed methane. Did it help protect groundwater at that time? No. This is a study that was done comparing coal bed methane isotopes and contamination problems in water wells in the Roosevelt area. So, what we really have a case where if something happens that the immediate damage is cleaned up, things are made to look good, but the farmers are left to live with the impacts of the true contamination. CAP's final point about induced seismicity and hydraulic fracturing has been covered by many. I just want you to notice, of course, that Alberta really at this point does not have a lot of problems with earthquakes, and we hope it will stay that way. The BC Commission study was covered last night quite well, saying that yes, there have been connections between fracking and earthquakes. What I did want to point out in that study is they talk about two parts, hydraulic fluids and injection waste, and they want to make those separate. The reality is they're both wastewater from the same industry, and whether this quake is small or large, it still has an impact. So are we just playing with words here? Maybe when we come to looking at the impacts that it's having, maybe we just have to turn around and look sometimes. Now, if, in our opinion, as landowners, what we're seeing is more cracks, more fish. We've seen more presentations, more ads saying that this is all environmentally friendly and will not cause any harm to the people. We look at the trees, lakes, and rivers. What would they say if they could talk? We all are very familiar in this area, the sour oil spill that happened in the Red Deer River. We realize it was not connected to fracturing, but it's an indication that the rivers and lakes are being impacted by the industry. These are trees just west of our house, and what people have been, I guess, shocked at is we've taken these pictures about the same time every year, and the die-off is increasing to the right-hand side of the tree plot. That was in the space of 2 years, the difference between what was alive and what was dead 2 years later, and now we've got one 2 years later from that. The die-off is almost right to the end. There's a few still looking healthy evergreens on the end of that wood lot, but something's happening there. And when things don't make sense, as stewards of the land, it's our heartfelt feelings. You've got to look and see what's going on here, what really is causing the problems. So when we start to connect the dots, we search out some facts, and we're very careful that we don't want to be confused by the fiction. And we hope that we've helped you to look at those aspects as well. And as Mr. Fitch said, ask the right questions.